We have used the addition, subtraction, and multiplication operators in our earlier videos already. In this video, we will expand on some of the inbuilt operators. These operators are used in C and C++ both. Most of these operators are also available in other programming languages like Java, C#, and Python. Welcome to CodeStation. Any operation, be it a mathematical or a logical computation, is performed using the combination of operands and operators. An operator performed the operation in the operands. For example, for this operation, 3 and 5 are the operands, and the addition operator plus is the operator. The addition operator basically tells the system to sum the values of the operands. Thus, it is already clear that operators are actually the foundation of any programming language. There are many inbuilt operators in C and C++. These can be classified into these groups. A unary operator takes only one operand to do the operation. Binary operator takes two operands. C++ also has a ternary operator which takes three operands. These operators can be subdivided as arithmetic operator, relational operators, logical operators, bitwise operators, assignment operator, and conditional operator. Remember, we had used input-output operators earlier. These are not listed here as they are not inbuilt and are defined in the IOStream file. The arithmetic operators are used to do mathematical calculations. The binary arithmetic operators are commonly known and used even while doing elementary math. The addition operator basically adds two operands. So this statement adds 6 and 2 and assigns an integer value of 8 to x. Subtraction operator subtracts the operand on the right from the operand on the left. Here, it subtracts 2 from 6 and assigns 4 to x. The multiplication operator multiplies two operands. Here, it multiplies 2 and 6 and stores 12 and x. Backslash is the division operator that divides the left operand by the operand on the right. Here, it divides 6 by 2 and stores the value of 3 in x. Note that 6 and 2 are both integer values. Therefore, this division operation returns an integer value 2. If we were to divide 5 by 2 instead, we would get a result of 2. An integer value, even if the variable that we stored the result was a floating point variable. If we were not expecting an integer operation and were expecting to get a 2.5 instead, we would need to convert one of the operands into a floating point variable. How do we do that? Well, just putting a decimal point on either of the value. Either having a 5.0 or a 5 point is both valid, and telling the compiler that this number is a floating point number. Finally, a percentage sign is the modulus operator that calculates the remainder when the integer operand on the left is divided by an integer operand on the right. Note that both the operands need to be integers for this operation. Also, the return type is an integer value too. In this example, this operation returns 1 because when 5 gets divided by 2, the remainder is 1. Similarly, this operation returns a 3. The lesser known arithmetic operators are the unary operators. The double ++ symbol defines increment operator that is used to increment the value of the operand by 1. Depending on where these operators are placed, they have different meaning. If they are placed before the operand, that is on the left side of the operand, they are called Pre-Increment operator. This operator does the value increment right away, even before the rest of the operations in the statement. A Post-Increment operator is when the increment operator is placed at the right side of the operand. This increments the operand value by 1 only after all the operations in the statements are completed. So, in this example, the value of x is pre-incremented to 4. The operation in the second line assigns this value to a. Since this is pre-increment, the increment happens before the operation completes. Thus, a is set to 4 as well. In this example, however, x is post-incremented. The rest of the operation happens before the increment of x. Thus, a is assigned the value of 3 first, and then x is incremented to 4. The decrement operator is two minus minus signs and is used to decrement the value of a variable by 1. Similar to increment operators, there are two flavors of decrement possible, a pre-decrement and a post-decrement. A pre-decrement value is decremented instantly. A post-decrement value is decremented at the end of the operation. So, in this example, we are using a pre-decrement and both a and x are 2. Similarly, while using a post-decrement, a is 3, the value of x before the decrement, and the decrement causes x to be 2. As an aside, when Bjarne Stroustrup chose the name C++ for his enhancement to the C language in 1983, he obviously had the post-increment operator in mind. Now, we move on to the relational operators. These are binary operators whose return type is bool. This means that when we apply a relational operator to two operands, we either get a true or a false as the result. Equality operator, two equal to signs, checks whether the two operands are equal. For example, in this case, we are comparing 10 and 7, which are obviously not equal. Thus, this operation returns a false. Similarly, this operation returns a true. The exclamation sign and the equal to sign is the not equal to operator. This operator checks if the two operands are not equal. If the operands are not equal, it returns a true. If they are equal, it returns a false. So, in this example, it returns a true. In this case, it returns false. The greater than sign checks if the left operand is greater than the right operand. If it is, it returns a true, else returns a false. In this example, 10 is greater than 7, thus it returns a true. In this example, 10 and 10 are equal. This means that the left operand is not greater than the right operand. Therefore, this returns a false. The equal to sign right after the greater than sign makes it a greater than equal to operator. This operator checks if the left operand is greater than or equal to the right operand. In this example, 10 is greater than 7, therefore it returns a true. Similarly here, the left and right operator are equal, therefore this returns a true. Similarly here, 10 is less than 15, therefore this operation returns false. Just like the greater than and greater than or equal to operators, we have a complementing less than and less than or equal to operators. In this example, 10 is smaller than 15, thus this operation returns true. Similarly, 10 is not smaller than 7, this returns false. 10 is not less than 10, this returns false as well. While using the smaller or equal to operator, this operation returns true as 10 is less than 15. 10 is neither smaller nor equal to 7, thus this returns a false. However, this operation comparing 10 and 10 returns a true. Logical operators are used to combine two or more conditions. In C++, logical AND operators are two ampersand signs. They are used to check if the two operands are both true. So, if both the operands are true, the AND operation returns a true. If either or both the operands are false, the AND operation will return a false. So, if the operand at the left is false, the AND operation will not bother checking the operand at the right. In this example, x is 5. R1 is true because both the conditions are true. R2, R3, and R4 are false. Logical OR is represented with two pipe symbols. OR operation checks if either of the two operands are true. Only if both the operands are false, the OR operation will return a false. Otherwise, it always returns a true. Also, it is important to note that if the left operand is already a true, the OR operator will not bother checking the operand at the right. In this example as well, R1 is true because both the operands are true. R2 and R3 are also true, as the left operand in R2 is true and the right operand in R3 is true. true. R4 is false, as both the operands are false. Logical NOT is represented with an exclamation mark. This is a unary operator, accepting only one operand. This operator simply checks if the operand is true or false. If the operand is true, it returns a false, and if the operand is false, it returns a true. You could read it as not true is equal to false. Not false is equal to true. In this case, R1 is false, as x is actually less than 10. Similarly, R2 is true, as x is not equal to 3. Of course, this could be and actually should be written differently. So rather than expressing this statement as not x is less than 10, we could simply represent it as x is greater than or equal to 10. Similarly, we could represent the second statement as x is not equal to 3. These are using the relational operators that we've already discussed earlier. The final kind of operators that we're going to discuss in this video are the so-called assignment operators. These are used to assign values to variables. The simplest of the assignment operator is just a single equal to sign. Recall that we've already used this operator in our earlier videos. Also, this is different compared to the relational equality operator. When we use the double equals to sign, this is the relational operator, where we are comparing the values of x and 10 and returning if they are equal. If we use an assignment operator instead, with a single equal to sign, we assign the value of 10 to x. Notice how the value on the right is assigned to the variable on the left. This implies that the operand on the left needs to be a variable or an object that can be assigned using the assignment operator. Thus, while it is possible to have two constant as operands with the relational operator, it is not possible to have a constant as a left operand with assignment operator. The combination of plus and equal to operator first add the two operands and assigns this value to the variable at the left. So, in this example, first x is set to 2. Notice how we use the equality operator for this operation. Then, we use the plus and equal to operator to add 3 to 2. Thus, the value of x is now 5. The combination of minus and equal to operator is similar. Subtracts the value at the right from the operand at the left and then assigns this value to the left operand. So here, the value of x is first assigned as 2. Then we subtract 3 from 2, which returns a minus 1. Thus, the value of x is minus 1. Similarly, there are other assignment operators using each of the arithmetic operators. The asterisk and the equal to operator obviously multiplies the operands. The backslash and the equal to operator divides the left operand by the right one. The percentage and equal to operator calculates the modulus when left operand is divided by the right operand. Thus, in this example, x is first set as 8. Then we multiply 8 with 3 and assign 24 to x. Then we divide 24 by 4 and assign x to 6. Now the modulus operator acts on x, which is 6. 6 modulus 5 is 1. So x is assigned as 1. Other than these, there are bitwise operators and ternary operators available. We will not discuss these in this video. We will have a separate video on bitwise calculation. On the other hand, we will be discussing the ternary operations while discussing conditional statements. Please subscribe to my channel for these videos and much more. Also, let me know how you like these videos. Thank you for watching.